Solve the quadratic inequality. Enter your answer using interval notation, and if there's no solution, then enter no solution. Here we have the quadratic inequality where x squared minus 10x is greater than negative 24. So the first thing we're going to do is we're going to add 24 to the left side of the inequality. So we get x squared minus 10x plus 24, and that's greater than 0. Now the next step is we want to be able to find the critical points. So in order to find the critical points, what we want to be able to do is we want to set this quadratic equation equal to 0. And then we're going to factor. So when we factor, we want to figure out, okay, what two numbers can we multiply to get positive 24? Then when we add them together, it's going to give us negative 10. Well, it's going to be negative 4 and then negative 6. So therefore, when we factor this, we end up getting x minus 4 times x minus 6, and that's equal to 0. And now we're going to solve both x minus 4 is equal to 0 and x minus 6, which is equal to 0. So we get x, which is equal to 5, x is equal to 4, or x is equal to positive 6. So therefore, we know that our critical points are located at 6 and 4. Okay, so now we're going to use the number line to create our regions. So we have 0, we have 4, and then we have 6. So now let's go ahead and create our regions going through our critical points. And now we're going to create our intervals. So we have region 1, we have region 2, and then region 3. So in region 1, we're going to go from negative infinity all the way to the value of 4. Now, in order to know whether it's a parenthesis or a bracket, well, this says greater than. So that means it's not greater than or equal to, so we have a parenthesis. So the first interval goes from negative infinity to positive 4. Next, we have the interval in region 2 that is in between 4 and then 6. And then region 3 goes from 6 to positive infinity. And so now what we want to do is we want to take a testing point for each region. So in region number 1, we can pick the value of 0. And then we're going to plug it into the inequality x squared minus 10x plus 24, and let that be greater than 0. So if we plug in 0 squared minus 10 times 0 plus 24, well, what's left is 24, and 24 is greater than 0, so that tells us that it's true in region number 1. If we take a look at region number 2, if we pick a value in between 4 and 6, we can pick 5. So again, using the inequality, x squared minus 10x plus 24 to see if that's greater than 0. Now, let me pause here. Okay, do we have to use that inequality? No. Okay, so what we can use is the same thing that we have here with what was it factored. And what we factored was x minus 4 times x minus 6, and that's greater than 0. That's the same thing. And it might be easier to check, because if we put 5 and we subtract 4, and then if we take 5 and then we subtract 6, so we get 1 times negative 1. And so negative 1 is not greater than 0. This is false, so we know it's false for region number 2. And let's take a look at region number 3. We can pick the value of 7 since it comes after 6. And again, we're going to use x minus 4 times x minus 6 to see if that's greater than 0. So we have 7 minus 4 times 7 minus 6 and see if that's greater than 0. So that's 3 times positive 1. And we know that 3 is greater than 0. So it's true for region 3. So what we want to be able to do now is determine where it is true. So we know that it's true in region number 1. So therefore there is our interval, and it's also true in region 3. And so now we can write our answer as the following inequality. It's going to go from negative infinity to 4, and then union 6 to infinity.